Welcome back, Thursday, March 26th. This is the last day of 8.4 trigonometry notes. Today we're going to be looking at the inverse trigonometric ratios. So in the first example of our notes on 8.4, you found that the sine of 42 is approximately 0.6691. It follows that if the sine of an angle is 0.6691, then the angle measures approximately 42 degrees. So if you know the sine, cosine, or tangent of an acute angle, you can use a calculator to find the measure of the angle, which is the inverse of the trigonometric ratio. So the inverse trig ratios are the following. They have like this power, I guess you would, to the negative first. So the expression inverse sine of x is how we read this. And it is interpreted as the angle with sine x. So we're going to study these inverse trig ratios. And in order to get them on our calculator, you're going to have to press the second button. And then after you press second, you'll press sine. And if you see on your calculator, if you follow this key, you get the inverse sine of x. Here, if you want to get the inverse cosine, second on our calculator is that blue button, and then you'll press the cosine, and that will give you the inverse cosine. And lastly, same thing for tangent. You would press second tangent button, and that will give you the inverse tangent. All of these buttons allow you to find angle measures. And that's what the inverse sine, inverse cosine, inverse tangent allow you to do. So if I want to find the angle measure for a given ratio, all we need to do to find that angle measure is use the inverse trig function. To get the angle A by itself, we'll use the inverse trig function. So suppose I have some sort of setup here, and I'm like, how can I get angle A by itself? What you're going to have to do is you're going to have to take the inverse sine of both sides. And when I do that, the inverse sine and the sine undo each other, and I'm left with angle A equaling the inverse sine of the opposite side over the hypotenuse. Here, I'll do this for the cosine. I'll take the inverse cosine of both sides. And when I do, again, these two undo each other, and that's why angle A is the inverse cosine. And finally, for tangent, to get the tangent, inverse tangent of both sides. And we get that angle A is left on the left-hand side, so angle A is the inverse tangent of the opposite side over the adjacent. Here's our first example. It says, use the calculator to find the measure of angle P to the nearest tenth and then to the nearest degree. So this is the angle measure I'm trying to find. I want to find angle P. I don't know that angle measure. So looking at here, I'm going to say, all right, well, what sides do I have in terms of angle P? Well, remember, this is the hypotenuse because it's pointed opposite of that right angle sign. So the right angle box is pointing towards my hypotenuse. So I'm going to label this as the hypotenuse. And then that means RP right here is the adjacent side. So I have adjacent hypotenuse. If we were to write out our phrase, SOHCAHTOA, we have adjacent hypotenuse. So I'm going to say the cosine of angle P, and that is equal to 13/19. Well, I just told you earlier, if I want to get angle P, I have to use the inverse cosine. So it's going to be the inverse cosine of 13/19. So on my calculator, I'm going to press the second button, cosine, and then I'm going to get 13 divided by 19. And when you round that to the nearest tenth, you get 46.8. So that is roughly 47 degrees. Same set of instructions here, but this time I need to find the measure of angle D. So sometimes you'll see they might call that theta right here. That's the Greek letter theta to let you know that that's the angle we're looking at. But I'm being specific. I'm telling you I want to find that angle measure right here. So I look again in terms of angle D. This is O and this is H. So TOA. So I have O and H. That means I have to use the sine. So I'm going to say the sine of angle D. That is equal to 16/23. So angle D is equal to the inverse sine of 16/23. So again, second sine, and then we'll do 1/3 divided by 2/3. All of those are the buttons that I would push on my calculator to get this answer. So the inverse sine, 16/23, and I get 44.07. So 44.1 degrees, and that is approximately, to the nearest degree, 44 degrees. Look at example number 3. The question mark is the angle I'm trying to find, so I'm going to call that X. Again, if I wanted to find this, I need to look down here and set up my ratio. I've got the opposite side, I've got the hypotenuse, so this is the sine of X, and that is 20/27. So what does X equal? It is the inverse sine of 20/27. And this time I want you to tell me what is that answer to the nearest degree, and I get 48 degrees. Looking at example number 4, again, this is the angle I want to find. I don't know, so I'm going to call that X. This time I have the opposite side and adjacent. So TOA, that lets me know I have to use the tangent ratio. So I'll say the tangent of X is 28/47. So X is equal to the inverse tangent of 28/47. You'll press the second button first, then tangent, 28 divided by 47. When you do, you get approximately 31 degrees. Alright, so now we're at this example that says solve the right triangle. If you see where it says to solve the right triangle, that means I want the missing side length and the remaining angle measures. So it doesn't matter where you start, we just have to choose a starting point. So some of you might like to go on and find the side length. And this is where we go back and we use our skills of using the Pythagorean theorem. It's been a while. Remember, this is a leg right here. BC is the leg, AC is the leg, AB is my hypotenuse. So the Pythagorean theorem said leg squared, so 4 squared, plus other leg squared, 7 squared, that is AB squared. So 4 squared is 16, 7 squared is 49, that is AB squared. I get 65 is equal to AB squared, and we are told that if we want to solve this, in order to solve it, we had to take the square root of both sides. So when I take the square root of both sides, I get that AB equals the square root of 65. But this time it said round my side measures to the nearest hundredth. So I'm going to take the square root of 65 on my calculator, and that is 8.06. Now, if we want to find the measure of angle A here, or if I want to find the measure of angle B, I can. I'm going to start with angle A just because it's first. So if I look at angle A, this is opposite of angle A. This is adjacent side to angle A. So I'll say that the tangent of angle A is 4/7. So that means angle A equals the inverse tangent of 4 divided by 7. So on my calculator, inverse tangent, 4 divided by 7, I get 29.744. So that's roughly 30 degrees. And now we know that all triangles add up to 180. If I wanted to find angle B, I would say angle B is equal to 90 minus angle A. So that is 90 minus 30, which is 60 degrees. I'm going to let you guys attempt to try this problem on your own. I'll fill in the work here in about 10-15 seconds, but just wanted you guys to attempt this one on your own. To go back to what Azara said, you got to check yourself before you wreck yourself. I know he's been waiting for that shout out, so there you go. You might want to pause the video. The answers will be coming up. Okay, here are the answers. I hope everyone found success. Please check Schoology for your assignment.